Hello, welcome. This is going to be problem 26, and problem 26 says, what is the value of x in the solution to the system of equations below? Okay, whenever you have a system of equations, you want to be able to cancel one of the variables. Right now, if you notice, the x's don't cancel, nor the y. So what you can do here is, because I have positive 3 and here I have negative 1, what I'm going to do here is I'm going to multiply the bottom equation by 3. That means I'm going to multiply every single term in this equation by 3. So this would be 9x. 3 times negative 1 is negative 3y. And then 3 times 4 is 12. The top equation, I'm just going to leave it as it is right now. Okay? So this would be 6x plus 3y equals 13. So if you notice, before there's nothing that cancels, but now 3y minus 3y cancels. So basically I cancel them out. 6 plus 9 will be 15x, and 13 plus 12 is 25. To get the x alone, we're going to divide by 15. Whoops. And the 15 cancels, you're left with x alone. We're going to divide top and bottom by, we're going to try to reduce the fraction by dividing top and bottom by 5. So 25 divided by 5 is 5. And 15 divided by 5 will be 3. Okay? You can also use your calculator. Basically, go ahead and quit from the table. And we're going to enter 25 divided by 15. That's what we have over here. And if you notice, we get a decimal. So all we have to do is change to a fraction by pressing math, number 1, and enter. And we get the same answer. So the answer here will be letter G. Okay? Alright, very good. Let's go on to problem number 27, which says, what is the zero of the linear function graph below? Here I have a graph, and I'm asking for the zero. Remember, the word zero, there's other words that mean zero. The other words are solutions. Also, x-intercept. Or roots. Okay? In this case, the problem asks for 0, but the one that really helps us is x-intercept. So if you notice right here, what is the x-intercept of this line? The x-intercept would be 1. And that's it. Your answer then is 1. Okay? Alright, let's go on to the next problem, which is problem number 28. Problem 28 says, the function y equals x squared plus x minus 6 is graphed below. So here's our graph. What are the values of x when x squared plus 6 plus x minus 6 equals negative 4? Okay, because I have a graph, basically here's the graph of this function. Okay? Basically, the graph is asking, when will y equals negative 4? So if you notice negative 4 here, we have two values right there, which would be value 1 and negative 2. So then the answer would be letter G. Now, I want to take this opportunity to say, let's say that I do not have this graph, okay? And let's say the problem says, just this. What are the values of x when x squared plus x minus 6 equals negative 4? What you can do is go ahead and turn on the calculator. Go ahead and clear your y value. Let's go ahead and enter this equation. X squared plus x minus 6. Okay? So basically, I put this function here on this side in the calculator. And this function says that equals negative 4. So basically, I go to my table, go ahead and delete everything that I have there, and let's try negative 4. If I plug it in negative 4, do I get negative 4 for y? No, I don't. So I know that this is not my answer. How about negative 2? Do I get a negative 4? Yes, I do. That's a confirmation that is correct. Let's try 1. I also get a negative 4. That tells me it's my answer. Just for the sake of checking, let's go ahead and do negative 3. And 2. And negative 5. And negative 6. Okay? A lot of students sometimes they will pick this one. Okay? Because most of the time the problems give you this. Alright? So that's why you need to be very careful and pay attention to what the problem is asking, because this problem is not asking when this equation equals negative 4. I'm sorry. This problem is not asking when x squared plus x minus 6 equals 0. Is rather asking when it equals negative 4. Okay? So please be careful. Make sure that you pay attention what is it equal to, because you want to see that number on the graph. Okay? If you had a problem like this, then you want to see the 0 showing up on your table. Okay? So then your answer would be negative 3, 2. Okay? So please be careful. Make sure you pay attention to what the problem is asking. Okay? Alright, let's go on to problem number 29. The problem 29 says a store manager begins each shift with the same total amount of money. She keeps $200 in a safe and distributes the rest equally to 5 cashiers in the store. This situation can be represented by the function y equals x minus 200 divided by 5. What does the x variable represent in this situation? Okay, so basically the problem is saying that a store manager starts out the day with begins each shift with the same total amount of money. She keeps $200 in the safe. So basically she starts out with some money, takes $200 and put in the safe, and then whatever is left she divides among 5 cashiers, okay, in the store. Alright, so basically that's the basically understanding we have of this equation. Now let's see the interpretation according to the multiple choice. We're looking for the value of x. The value of x is the total amount of money the manager has at the beginning of the shift. That is correct. Letter B, the total amount of money the manager has at the end of the shift. Nope. The amount of money each cashier has at the beginning of the shift. Nope. I mean, that would be what y equals to. Okay. The amount of money each cashier has at the end of the shift. No, that is not correct. So basically the answer is letter A. Okay. So the problem is asking what is the value of x. The value of x, it represents the amount of money they start out the day with. Okay. Minus the $200. I mean, and here it shows you that they're doing minus $200 and then dividing by 5. Okay. Alright, let's do problem number 30. What is the equation in standard form of the line that passes through 124 and has a slope of negative 0.6? Okay. Alright. The first thing I would do is, basically what I can do is, using this point right here, I could go ahead and quit and go ahead and do this. Plug it in the value of 1 and 24. Okay, so let's do 3 times 1 plus 5 times 24. And if these numbers are correct, and if this equation is correct, I should get 125. And let's see, what do I get? I get 123, so that is incorrect. And in fact, this problem is pretty easy because they kept all the numbers the same. So basically we can see that the one that's going to give us 123 is letter H. Okay. And in fact, here where it says slope equals negative 0.6, if you want to just double check, you don't really have to double check because all the equations are the same except for the what they're equal to. But basically, if you wanted to check the slope, get the y alone. So you would move the 3x to the other side. And then you divide both sides by 5. So this would be 123 divided by 5 here. And 3 cannot be divided by 5, so I'll just keep it as 3/5. And as you can see, 3 divided by 5 is 0.6, so negative 0.6. Okay, but since all of them has 3x plus 5y, they're all going to have the same slope. Okay, but it could occur that on the new question that they're going to throw at you, they might have different numbers here, and then the slope would come into play. For example, let's say here was, let's say they had, instead of this, they had 2x plus 5y equals 123. So basically, both equation equals 123, and you might want to check your slope. Okay. All right. So that's problem number 30. Let's go ahead and problem 31. Problem 31 says, which coordinate pair is in the solution set for y less than 1 minus 6x? Okay, so basically what first thing I would do is try to graph this line. First, make sure you identify your m, which would be negative 6, which is your slope, and your b, which is 1. Remember, slope, you always want it to make into a fraction by putting a 1 underneath. And remember, slope, this is the rise, and this is your 1. Alright, so let's check how we're going to graph this. Okay, according to this, we always start with the letter b, and the letter b is the y-intercept, so it's on the y-axis. So we're going to start our graph at point 1. Now, one thing you need to be careful is, if you have these symbols, that means your line is going to be a dashed line with empty circles. And if you have less than or equal to, or greater or equal to, you're going to have solid points with a solid line. So in this particular problem, I have less than, so that means my points are going to be empty points. So I'm going to start at the y-intercept, which is 1, with an empty point. And then, using the slope, I'm going to go down 6. So 1, 2, 3, 4, 5, 6. And I'm going to run 1 to the right. Remember, you always go to the right first. And then you go down 6 again. So 1, 2, 3, 4, 5, 6, over 1. Alright, once you fill in the right side, go back to the starting point and go the opposite way the slope tells you. So instead of going down 6, you're going to go up 6. So 1, 2, 3, 4, 5, 6, and 1 to the opposite side, which means to the left. And then you go up 6 over 1. Okay, with that, you can draw a line, a dashed line. Okay, and now we want to graph, we want to shade at the region that is less than. Less than means below this line right here. So below this line would be this side right here. Okay, whenever in doubt where to shade, just pick a point. Let's say I pick this point, and ask yourself, where would be the numbers less than on the y-axis? The numbers less than this point right here on the y-axis would be below, right here. Okay? Alright? And that way you know that your shading would be on this region. Okay? Alright, now that we know what the region is, what the solution is, okay, we can kind of shade it there to give us a better idea. Now we're going to plot this point, and we're going to figure out which one is part of the solution. Which one of these is in the shaded region. So let's see. 1, 0. 1, 0 will be right there. And that's not part of the solution. Then we have 1, negative 1. Again, not part of the solution. 0, 1 is right on the line. But because the line is empty points with dashed lines, even though this point is right there, that is not part of the solution. If it was a solid line, it would be part of the solution, but because it's a dashed line, it's not part of the solution. And the last one would be negative 1, 1, which should be right there on the shaded region. So letter D is the correct answer. Okay, so please be very careful. Okay, let me highlight it. Try to see if I can highlight this. Okay, where you can see the points. Let me bring it closer. Okay, as you can see, this point is the only point inside the region. Okay, please be very careful. If a point is on top of a dashed line, is not part of the solution. They like to give this answer, this kind of problems to you, and notice that that point is come before the right answer, because they're betting that you're gonna be so excited that the point lands on that line that you're not gonna pay attention to the last multiple choice. Okay, because if you did, you would see that, wait a second, this point is on the region, so then you would have a question, which one is the right answer? And then you would think of, oh, wait a second, this line is shaded, so this is not the answer. So what I'm saying is, please be very careful with shaded dashed lines, because if the point lands on it, it's not part of the solution. Okay. Alright, very good. Let's go on to problem number 32. Okay, problem 32 says, which graph does not represent a function of x? Okay, basically this, to be a function of x on the graph, basically what you do the vertical line test. Basically, you move like your pencil across the graph, or you imagine yourself a line, such as, let me use my paper clip over here. So just a moment here. Basically, if I move this paper clip across, I can see that I'm only touching one point at a time. So that means this is a function. If you notice here, letter G, well, is also a function. Letter J, also a function. But letter H, right there, you can see that I'm touching multiple points on the line. Okay? For example, I'm touching 1, 2, 3, 4, 5 at a time at that particular point. Okay? So we know that which one does not represent a function would be letter H. Alright, so let's take a look at problem 33. This says the graph of line P represents y equals 1/5 x minus 1. If the slope of the line, if this slope is multiplied by -10 to create line R, which statement about the graphs of the two lines is true? So basically, if I multiply this guy by -10, and you can even do it in the calculator here, let me see here, let me clear my screen, and we have 1/5 times -10, we get -2, so this means this will change to -2, -1, okay? So basically, we have two lines. This is line P, and this is the new line, line R. And question is, which statement about the graphs of the two lines is true? Okay, let's do this before we even read the multiple choices. Let's graph these two lines using our calculator. That will give us a better idea what the graph looks like. So let's clear the Y screen. Let's enter the equations. 1 divided by 5x minus 1 and -2x minus 1. Alright, so let's press graph, and that will be my first line, and the next one will be my second line. As I can see, the two lines intersect, and now I have a better idea on the screen, also over here on what I'm looking at. And let's say which statement is true. Line excuse me, line R intersects line P. Well, that is correct. Line R is parallel to line P. That is false. Line R is 10 units above line P. Basically, if I had line R like this and line P, I'm sorry, basically what they're saying is, here's a line P, and 10 units above would be line R. So basically they will be parallel, okay, and that is not true. Okay, line R is 10 units below line P. That is not true. So basically the right answer is letter A. Okay, so here is a problem where the calculator was able to help us solve the problem. Okay, alright, let's go on to the next problem. Alright, a table of values for the quadratic function is shown below. Okay, And if 3 is one solution to f of x equals 0, what is the value of the other solution? Okay. Alright, if 3 is one solution to f of x equals 0, what is the value of the other solution? Alright, remember solution is the same thing as roots, is the same thing as x-intercept, is the same thing as zeros. Okay, so in other words, basically, if I graph this point, they're going to intersect the x-axis at some particular points. Okay, best thing I would do, the one thing I would do in looking at this problem is I would sketch a graph. You can either use the grid that they give you at the beginning of your test. Okay, remember you can use that to graph lines, or on this particular problem I can just graph them very easily. It doesn't have to be perfect. Okay, basically just lightly with your pencil. Alright, we notice that we have negative numbers, so let's go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and we have 0 and 1. Alright, and on these numbers we start at negative 2.75, so let's go down negative 3, and then let's go up 1, 2, 3, 4, 5, and 6. Okay, alright. So let's try to graph the first point, which would be negative 8, and negative 2.75, which would be somewhere in here. The next point would be negative 7, 0. Alright, then the next point would be negative 6, 2.5, so 2.25 would be somewhere in here. Alright, so we got that. So let's do negative 5. And 4, 1, 2, 3, 4, so it would be right there. And then we're going to have negative 4 and 5.725, so 1, 2, 3, 4, 5, 25 would be somewhere in here. And then we have negative 3, 6, negative 3, 6, there we go. And then we're going to have negative 2, 6.25, so it'll be somewhere in here. And then we're going to have negative 1, 6, right? So negative 1, 1, 2, 3, 4, 5, 6, right there. And then we're going to have 0, 5, 25. And then we're going to have 1, 4. So 1, 2, 3, 4. Alright, so basically I have something like this, right? Alright, the problem tells us if 3 is one solution, in other words, one of the x-intercepts, so basically the problem is telling me that this is one of the solutions. What's the other solution? Well, the other solution would be this guy right here. How do we get this point? 1, 2, 3, 4, 5, 6, 7. So the answer would be negative 7. Okay? So basically the solution is negative 7. And you can see it right there on the graph. Okay? So again, here's another problem where the keywords solution, roots, x-intercepts, and 0 come into play. Okay? Alright, let's go on to the next problem. Okay? Problem number 35. And the problem 35 says, a print shop charges a fixed amount per copy and gives a 10% discount off the total cost of the photocopies. The total cost is a function of the number of photocopies made. What is the independent quantity in this situation? Alright, so basically, if I was to create an equation, this would be the cost equals, okay, the so let's say it costs 10 cents, okay, to make copies, okay? So 10 cents. So that would be 10 cents per copy. So so let's say photocopy, so P, let's use photocopy. So 10 cents per photocopy, okay? Now the problem says that this particular shop gives you a 10% discount. Okay, so that means we're not charging 100%, we're charging only 90%. Anytime you do percentage, change it to decimal. So 90%, change to decimal. All you have to do is move the decimal point, which is right here, 2 decimal places to the left. So that means this will become 0.9. So basically this is, you're going to multiply by 0.9. So basically the cost equals 90% of 10 cents per copy. Alright? So basically this is your equation. Now, when he asks you for the independent variable, most people would think the independent variable is the one that is by itself, but that's counterintuitive. The independent is the one that has numbers around. So this would be your independent variable, which means the number of photocopies. Independent. Okay? So basically, which one is the independent quantity? The total cost of the photocopies? Nope. That's dependent on how many photocopies you made. The price per photocopy? No, that's fixed. The amount of the discount? Discount has nothing to do with independent or dependent quantity. The total number of photocopies made? That's your independent. Okay? So please remember, independent variable is the one that has numbers around. And the dependent, the one that depends on something, is the one that is by itself. Okay? So let's go on to the next problem. Problem number 36. Problem number 36, they give me a set of order pairs. And they're asking, what is the parent function of f? Okay? So basically, this is asking for the parent function. Okay? So basically, this here is called a linear function. Basically, your line, what you're gonna get when you produce this line is a straight line, something that looks like that. Also, this one would be something that looks like this. Okay. The other one is a quadratic that looks like a parabola. Okay. And the last one is something that looks like this. A parabola only half size, just one side of it on the positive side, and is facing this direction. Okay? So these are the four parent functions. Okay? Alright? And basically what the problem is asking is, if I plot these points, which one would look like something like this? Again, this would be a place where you would plot the points, What I would do then is you can either use your coordinate plane that the test provides you, or you can quickly sketch a graph. So just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, basically I created a quick graph right here for me, and I'm going to plot these points. Okay, and I notice it goes all the way to 11, so I'm going to add one more tick mark there. Basically says my first point is going to be 3, 11, so I'm just going to kind of go 3 up and 11. So that's my first point. And then the next one is going to be negative 1, 3. Whoops. Negative 1. And we're going to go up 1, 2, 3. So that's my point right there. Then I have 5. So 1, 2, 3, 4, 5. And This is 11, 12, 13, 14, 15. So that's my point right there. Alright, start seeing it looks like a straight line, but let's double check again. Negative 4, 3. 1, 2, 3, 4. And then we're going to go down 3. Alright. And then we have negative 7. So 4, 5, 6, 7. And we'll go 1, 2, 3, 4, 5, 6, 7, 9. Alright. As we can tell here, this is going to be similar to this graph, so I know it's going to be letter F. Okay, this is the second problem that by sketching a graph, okay, we are able to visualize the problem and better answer the problem. Okay, now these are graphs that you need to remember. You know, the parent function of a linear is this line right here. This would be the exponential, this would be the quadratic, okay? The calculator can help you is if you forget how does the parent function look like, you can always graph it. So let's press clear here. And you can press the letter X and you'll be able to see the graph right there, how this graph looks like. Compare that to the second one, which is 2 raised to the x. Okay, so let's press graph. So as you can see, you started and go up. And let's do the other one. And if you have too many graphs, it'd be kind of hard to see. So let's go ahead and clear that and clear that. And let's just enter 1 right now, x squared, and press graph. You'll be able to see the parabola. And let's try this one here. So press Y and let's press the square root of x. Whoops. Make sure you clear first. So second. Whoops. Not my day today here. Second square and then x. Alright, we got that. And you see the graph right there. Okay. So always in doubt, use your calculator, do some sketching, and you'll be able to identify very clearly which one is the parent function. Okay? Even though this line is not exactly the same because this line goes through the orange, and remember, the parent function is where this graph originated from. Basically what we did is we switched a little bit the slope and we moved the line up. Okay? That's why this is called the parent function, because this line originated from this parent. Okay? Alright, let's go on to the next problem. The problem says the average annual rainfall for a particular city is 32.2 inches. In the first 30 weeks of this year, the city received a total of 9.7 inches of rain. If it is expected to rain between 1.5 and 2.1 inches per week through the end of the year, what is a reasonable number of additional weeks needed for this city to reach its average annual rainfall? Okay? Alright, so basically the problem says that it already rained 9.7 inches. Okay? Alright. And it is expected to rain between 1.5 and 2.1 inches per week. So there's two options. I mean, the worst case scenario, the only thing that's going to rain is 1.5 inches per week. Okay? Or the other scenario could be 9.7 plus 1.5, not 1.5, 2.1 inches per week. Okay? And the question is, how many weeks would it have to rain 1.5 inches to give you a total of 32.2? And on the other side, if it's raining 2.1, how many weeks would it take to reach 33.2? Okay? So basically, here's two scenarios. This is going to tell me how many weeks if it rains only 1.5, and here how many weeks if it rains only 2.1. Okay, so basically we have two equations. We're going to solve for x. So basically we're going to move the 9.7 to the other side. So this would be 1.5x equals 33.2 minus 9.7. This would be 1.5x equals, let's turn on our calculator here, 33.2 minus 9.7. We get 23.5. Alright, let's divide that by 1.5. Okay, so 23.5 divided by 1.5 is 15.6. Okay, so if it only rains 1.5 inches per week, at the low end, we would have to, it would have to rain 15.6 weeks. Okay, not quite 16. And a lot of students will look at this and go ahead and go right into the letter G. Please be careful. Let's look at the other side. Let's say it rains a lot, and how many weeks would I need here? Alright, so let's move the 9.7 over there. So this would be 2.1x equals 33.2 minus 9.7. This would be 2.1x equals 33.2 minus 9.7 is 23.5. Divide that by 2.1. So 23.5 divided by 2.1 is 11.1. So on one end, I need to rain 11.1 till 15.6. So basically, my interval is between these two numbers. Now, between 11.1 and 15.6, which one of these multiple choice is a number in this interval? And the answer is letter B. Okay? Alright, so let's go on to problem number 38. Problem 38 says, a teacher collected data on 20 students for 2 different quizzes. The scatter plot below shows the relationship between the number of points scored on quiz 1 and the number of points scored on quiz 2. Okay, so basically the idea here, here's the points scored on quiz 1, here are the scores on quiz number 2. Basically what we see is the higher the grade on quiz 1, the quiz 2 start getting higher too. Okay, which statement describes the data? The number of points scored on quiz 2 was less than the number of points scored on quiz 1 for any students who scored at least 50 points on quiz 1. Alright, so basically they start to compare quiz 1 with quiz 2, and the one thing that I notice here is if I draw this line right here, okay, connecting the intersection right here, okay, basically this is going to be my line y equals x, okay. Okay, so y equals x. Okay, so basically what this means is, okay, remember y is quiz 2 and x is quiz 1. So basically this line is representing where both quizzes have the same score. Okay, and the points above this line represents the number of quizzes where quiz 2 was higher. Okay, and the points below the line means the quizzes 1 was higher. Okay, if you notice right here, for example, I got a 50 on quiz 1, but on quiz 2 I got a low grade. Versus here, any points above the line means quiz 2 got a higher grade. For example, if you notice, you got a 70 on quiz 1, and on quiz 2 I got an 85. Okay, so this is representing quiz 2 is higher. This is representing quiz 1 is a higher grade. Now the problem says the number of points scored on quiz 2 was less than the number of points scored on quiz 1 for any student who scored at least 50 points on quiz 1. Okay, so So basically, any students that score at least 50 points, that means 50 or higher, that means the number of points scored on quiz 2 was less than the number of points scored on quiz 1, and that is false because, as you see, quiz 2 was the better quiz here. So basically this is false. Alright, the number of points scored on quiz 2 was greater than the number of points scored on quiz 1 for any student who scored 50 or fewer points on quiz 1. So basically we're looking for this side of the graph from 50 lower. Any the students that scored lower than 50 on quiz 1 did poorly on quiz number 2. So that means letter G is false because it says quiz 2 was greater. Alright, letter H. The number of points scored on quiz 2 was greater than the number of points scored on quiz 1 for any student who scored at least 50 points on quiz 1. Okay, this is not be totally true. If you notice, most of the students that are above the line, but there's some students here that are not above the line, and that's the problem right here because it says for any students. Okay, so let's leave a question mark for this one, and then this one says the number of points scored for quiz 2 was less than the number of points scored for quiz 1 for any student who scored 50 or fewer points. So basically, any students that scored 50 or below, quiz 2 was fewer points, and that is correct because over here the points are below the line. So letter J is totally correct. Letter H, part of it's not correct, so it fails. Okay, so let's go on to question number 39. Okay, and it says the number of ferry boat trips F of C needed to transport C cars in a day can be found using the function f of c equals c over 20. If there are no more than 5,000 cars transported by ferry boat daily, what is the range of the function for this situation? Alright, so here's my function. F of c equals c over 20. Okay, in other words, y equals x over 20, right? And the problem says there can be no more than 5,000 cars. So in other words, this letter C, which is x, has to be less or equal to 5,000. Okay? Alright, so that means if I put 5,000 here, y equals 5,000 divided by 20, that means y is 250. Okay, so that means the number of ferry boats, the maximum that you could have is 250. And so basically, in a particular day, you can only have 250 trips. Okay, all right. So let's see here. The set of, and basically the question is, what is the range? That means we're talking about the y value. The set of all integers greater than or equal to 5,000. Nope. Set of all integers 0 to 5,000. Nope. We know that we want to use the number 250. The set of all integers greater than or equal to 250. Okay. We know that we have a limit of 5,000 cars, so that means there can be no more than 5,000 cars. So that means this number cannot be bigger than 250. Okay, so that is false. The set of all integers from 0 to 250, that is correct, because you can, like maybe one day there's no cars that show up, and maybe another day all 5,000 cars show up, so that means you're going to have 250 trips. So that will be letter D. Okay, next question. This question says, a high school band held a bake sale. The number of cupcakes sold was 4 more than twice the number of cookies sold. The band sold a total of 52 cupcakes and cookies. How many cupcakes were sold? Okay, So let's read the problem again. A high school band held a bake sale. The number of cupcakes, so let's call cupcakes letter C, sold. So the number of cupcakes sold was is a key word that means equal. 4 more, so 4 more than twice the number of cookies. Well, we already used the letter C, so for cookies we're going to use letter K. So basically the number of cupcakes is equal sign 4 more than twice the number of cookies. Then the second phrase says the band sold a total of 52 cupcakes and cookies. So basically in this problem you have cupcakes plus cookies. The number of cupcakes plus cookies equals 52. So basically here I have a system of equations. Basically what I can do is use substitution. Basically instead of using letter C, I notice that my first equation says C equals 4 plus 2K. So I'm going to substitute that into my second equation. So I'm going to plug it in 4 plus 2K. And the rest I'm just going to copy as it is. And would you look at that? That is an equation that I can solve for K. So let's go ahead and solve for K. So basically this would be 4 plus 3K equals 52. So we're going to move the 4 to the other side. So this would be 3K equals 52 minus 4. This would be 3K equals 52 minus 4 is 48. And then we divide this by 3. And K equals 16. Now you need to be very careful. Whenever you get an answer on... Sorry, you were not able to see this, but basically I did move the 4 over there, got 52 minus 4, and then 52 minus 4 is 48, then I divide both sides by 3, got 16. Now right here, when you get an answer, you need to stop and say, is this what the problem is asking me to find? Because this is the number of cookies. Read the question. The problem says, how many number of cupcakes did we sell, were sold? Okay, so basically we're going to go back here to this circled equation, which is C equals 4 plus 2K, and we're going to plug it in this value of 16. 4 plus 2 times 16. So we multiply 2 times 16 is 32, and 4 plus 32 is 36. So we can see the number of cupcakes is 36. Now, would you take a moment and look over here? You see number 6, letter G right here? Is the same number as letter K. And why do they put that before the right answer? Because they're betting that most students will solve all the way up to here, get so excited that they see 16 here and 16 there, and they get like, oh, that's my answer. Please be very careful. Once you get the answer, double check, is that what the problem is asking me to solve? Okay? So we're going to stop this part of the video right now. And if you want to continue to the next part, please go back to the website and click on the next part. Alright? Thank you very much for your time. Have a great day.